Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So we're going to talk about addition and subtraction of vectors using the parallelogram law, all right? So this is the third one, but I'm going to break this video into two parts. The first part, I'm going to write all the formulas and explain the concept of the parallelogram law. Then the second video or the second part, I'm going to solve some question on it. So it's very important you take note of this first part, because if you don't understand this first part, you won't be able to solve the second part. Is that all right? Good. So let's get cracking then. The first thing I want you to know is that how rules of drawing parallelogram. So just to remind ourselves, a parallelogram has two sides that are parallel. So the parallelogram looks like this. So you have two sides that are parallel to each other. It's a parallelogram. So, but in this case, that what happens is that if you remember what we talked about the head to tail method, we said when you have A, then you had B, they now join it to give you A plus B, right? But in this case, it's not going to be that same way. Here, what happens is that you will have A here, but you see that both of them are going to what? Start from the same place. Now, when you've done with that, then you then have to then complete it to form a parallelogram. Are you seeing it? So that this part becomes parallel to this part, while that part becomes parallel to the other part. Are you seeing it? Then after that, the resultant is going to be a diagonal from this point all the way to this point, and that will give you the what? A plus B. So you can see for parallelogram, it's completely different from the head to tail or the triangular method. All right. So I'm going to write down what I've just said so that it will make sense to you. All right. So the first thing is that I'm going to just quickly write out the 3 steps to drawing a parallelogram, okay, for drawing. So it's going to be important that I do this before I go to the laws of the addition and the laws of subtraction. So the first thing you have to do, you have to draw the vectors so that their initial part, their initial point, coincides. Number 2, after you've done that, take this up a bit. Okay. The next thing, you have to now draw the lines to complete the parallelogram. So then you have to draw lines to form a complete parallelogram. Okay. Then number 3, the diagonal from the initial point to the opposite vertex of parallelogram is going to be the resultant. So the diagonal from the initial point to the opposite vertex, okay, from the initial point to the opposite vertex of the parallelogram is the resultant. Okay, so what I'm trying to say here is that let's assume I have a parallelogram. So we have a vector here. Let's say we call this vector V. Okay, and we have another vector here. Okay, let's call this vector U. Okay, so that's step 1. You have to start from they have to initially what? Have the same initial point. Then you now have to draw lines to form a complete parallelogram, step 2. So we're going to do that now. So we're going to draw lines to complete it. So you have something like this. Okay, so this is this one. Then this is going to be this one here. All right. Then step 3, which was what we talked about. We said for step 3 is the diagonal, all right? From the initial point to the opposite vertex is a resultant, all right? The diagonal is a resultant. So we're going to have, when you draw a line from this point all the way to the vertex there, is going to be the resultant. So it's going to be U plus V, okay? Or if you want to express it in terms of R or Q and P. So we can also do the same thing. You can have Q or you can have P. All right. Take this away. We can have P, okay. Then we can have Q. All right. So we'll do the same thing to complete it. Then we can now see that the resultant will be from this point all the way to this point. So this is going to be the resultant. So we can easily express this in mathematical form if you want to. So you can easily say for this parallelogram, so we have for the first one, U plus V will give you the resultant parallelogram to be U plus V. Does that make sense? Or if you want to write it in this way, you can say Q plus P will give you the resultant to be what? R. So you can write it in different forms, okay? So let's go straight to now the laws of addition and the laws of subtraction. So we use this parallelogram law for both addition and subtraction, okay? So now, since we now know the concept of parallelogram as resultant, so we can then go straight to see how do we use this parallelogram law for addition and subtraction. Okay, so I'm going to first start with addition. All right. So what will happen here is that if you have two vectors that are acting simultaneously at a point, now they can be represented in both magnitude and direction by the adjacent sides. So like what we said, that you have two vectors starting from an initial point and they grow. They can be represented in magnitude and direction from the initial side of a parallelogram drawn from that point. Okay? Then the resultant vector is represented in both magnitude and direction by the diagonal. So it's basically exactly what we did in the 3 steps. So you have the initial point. So basically what I'm saying is that you have the initial point of the two parallelograms, okay? Then you complete it into a parallelogram. So this is the straight up. And then the resultant is going to be that, okay? So that's what I'm going to say. So, but what I'm going to do, I'm going to write down the law here so that for students that are taking notes, then I'm going to just show you how the formulas that is going to be derived from this. So it says, if two vectors acting simultaneously, if two vectors acting simultaneously at a point, can be represented both in magnitude and direction by the adjacent sides of a parallelogram. Okay, drawn from a point. Then the resultant vector is represented so remember we're talking about the resultant, okay? Is represented both in magnitude and direction by the diagonal of the parallelogram. Passing through that point. Okay, so let's see if we can show this in diagrams. So same thing. So if you have, okay, let's assume we have a particular, we have, let's call this P, okay? And let's call this Q. Let's assume that they have an angle here, theta. Is that making sense? Now, what we are now saying is that the resultant, similar to what we said, is that you then have to then complete this to be a parallelogram, okay? And you have to complete this. So remember, they have to be parallel. Is that making sense? Then the resultant is going to be from this point all the way to that. So the resultant is going to be that. So therefore, we can now say R is going to be what? P plus Q. Does that make sense? So therefore, and also we can now say that if we now look at that, we can now figure out that R, we can also find the magnitude of R, which is going to be represented by this sign called the magnitude. So we're going to talk about magnitude very soon. I'm going to just introduce it here because I'm going to talk about how to find the magnitude of a two-dimensional vector than a three-dimensional vector. But how do you find the magnitude of R in this case? So the magnitude of R in this case. So what you can see is that we can then further draw this as well. So that means I can also represent this. So let's draw it again. So we have this, okay? And we have, let's say this is P, okay? And this is Q. I'll put it this way. So let's say this is Q, okay? And we've all agreed that it's going to be drawn in such a way that they have to be parallel, right? So let's assume it's parallel like this. Okay, so let's assume it's trying to get the right parallel lines for this. So it was parallel like this. Good. So let's assume it was parallel. And we've already agreed that this part here is going to be the resultant. Okay. And also this angle here is theta. Okay. But one thing you need to know is that if this angle is theta, but there's also an angle here, let's call this angle here to be beta. Is that making sense? So that means the whole angle there was theta, and that is beta. So what we can then do is that we can then decide to complete this to be a triangle. So you can draw this at this point here. Are you seeing it? And you can draw this at this point here. So if this is vertically opposite, so if this is theta, so this has to be theta as well. Are you seeing it? So now this is Q, so we can easily now say that if this is Q, that means this part is going to be Q sine theta. And this part is going to be what? Q cos what? Theta. All right. So like I said, I'm not going to go into the proof for all this, okay? So you can go to the textbook and find it. So now, then how do you now find the magnitude, okay? How do you then find the magnitude for R? So the magnitude for R is going to be given by, so the magnitude for R will be equal to the square roots of the magnitude of P squared plus the magnitude of Q squared plus 2 the magnitude of P, the magnitude of what? Q cos theta. So this is the first formula that you need to know when you're solving with parallelogram. Okay? So that is how you do it. Now, the question you now ask me, how do you now find the magnitude of P? All right? So the magnitude of P is equal to the square root of the square of the s component of P plus the square of the y component of P. So that means if you have, for instance, let's assume P was equal to 2 and 3, okay? So the magnitude is going to be equal to the square root of 2 squared plus 3 squared, so something like that. Is that making sense? So that's how you find magnitude. So we'll talk about this more, how to find the concept of magnitude later, but it's just important that you know that this is the formula for what? Magnitude. Is that okay? Now, also, similarly, we can also get the magnitude of Q. Okay? It's going to be equal to the same thing, the square root of the s component of Q squared plus the y component of what? Q what? Squared. And that is going to give you the magnitude of what? Q. Okay? Now, then we have beta. So beta is we can say the angle towards the x-axis with one of the components. So how do you find beta? So to get beta, so I'm going to use another different color for this. So it's going to be tan beta will be equal to Q sine theta divided by the magnitude of P plus the magnitude of Q cos theta, okay? And that will give you the value for that. Then the final one, how do you now get theta itself? Theta itself, which is the red one. So to get theta is going to be equal to the tan inverse of Q sine theta divided by P plus Q cos theta. And that is that for what? Theta. All right. So like I said in this video, I'm not going to be talking about how we arrived at this formula. So if you want to, you can either send me an email or we can talk about it if you meet me. But here I'm just gonna just state the formulas here. And in some exams, this formula is also part of the formula sheet, so you don't really need to memorize it. But in some, you have to memorize it, so you have to make sure you check with the examination you're writing. So basically, this is how you find the magnitude of R, or you find it the tan beta, or you find it the theta itself. Okay. All right, so that is that. So when you have parallelogram laws for addition, so now we're going to talk about how do we now do for subtraction. So now we just finished parallelogram law of vectors addition, and I've also talked about the formulas as well. So we're going to do the additions now. So how do you now do the parallelogram law of what? Subtraction, I beg your pardon. Okay, so let's do the next one, which is the parallelogram law. Used in vector subtraction. Okay, so basically, here it's still the same law as previous. So instead of you to, because it's subtraction, you have to flip it. Okay, so that's basically the same thing. So it's going to be same concept like subtraction. All right, so it's the same concept as subtraction. Okay, so we've talked about subtraction already. So if, for instance, we have Q and we have P, all right? And we're now told to find R, the resultant should be P minus Q. So we're looking for P minus Q now, all right? So what it means is that we then have to flip, because this is the same thing as saying P plus minus Q. Are you seeing it? So that means we have to flip the Q in the other direction, but we have to maintain the magnitude. So now we can now say that we're gonna have, so this is the P, all right? So we have the P. Now, normally the Q was in this direction, right? But now we need the negative Q, so it's gonna be in this direction. Are you seeing it? Then when we're done, we then have to complete this to be a parallelogram. So let's complete that now. So we then draw this one like this to be a parallelogram. And we'll draw this one. So it's going to be somewhere here. I'm going to draw this one like this to be a parallelogram somewhere here. So now the resultant is going to be from this point here to this point here. Okay? So it's going to be like this. And this is going to be the resultant, R. And the R is going to be the same thing as what? P minus what? Q. Are you seeing it? And that is it. And if we're looking for Q minus P, it's going to be the same thing. So if we're doing Q minus P now, it's going to be a little bit different. So if it's Q minus P that we're asked to find, so Q minus P So in Q minus P, okay, so it's Q is going to remain the same, but P is going to be what? Flipped. So if we're looking for R to be equal to, so this is for this one. So we're looking for R to be equal to Q minus P. So it's going to be same thing as saying Q plus minus P. Are you seeing it? So then the Q is going to remain the same, but we're going to flip the P. Is that making sense? So we're going to have it like this, Q, like this, okay? This is the Q. Now, ideally, the P was in this direction, but now it's going to be in this direction here. So this is where this, and this is going to be minus P, while this was the P, okay? So this is it. Then what we now do, we then have to complete this to be a parallelogram. So we're going to have this to be like this. And we're going to have that to be like this. Okay? So now the resultant is going to be from this point all the way to this point, and that will be the R. And the R is going to be equal to Q minus what? P. And that is it. So now in this case now, how do you find the R? So the formula for this is a bit similarly, but just similar to what we had here, okay? But instead of us having the positive sign, we're gonna have negative sign for the magnitude, but the other one remains the same. Is that okay? So so how do you get the magnitude of R in subtraction? Okay. So the magnitude of R is going to be equal to the square root of the magnitude of P squared plus the magnitude of Q squared. But instead of to have positive, we're going to have negative. So it's going to be 2 magnitude of P and magnitude of Q cos what? Cos theta. Okay. Then, but as usual, so this is going to be that. So let me just box that so that you know that that is the formula you need to know for that. Then how do you find the magnitude of P? Exactly the same thing we talked about earlier. It's going to be equal to the square root of the S component of P squared plus the Y component of P what? Squared. Then how do you get the magnitude of Q? It's going to be the same thing. The square root of the S component of Q squared plus the Y component of what? Q squared. And that will give you the answer for that. So it's going to be like that. Good. And that is how you do. Okay, so vectors are negative, so it's basically nothing. It's similar, but it's just that the vector, one of the vectors is going to be reversed, and you now have the negative sign, and you also maintain the what? The magnitude for both of them. Is that okay? So what I'm going to do, I'm going to try to see if I can summarize this into 3 steps for using parallelogram method, so that just since we now know all the laws for that, I'll see if I can summarize this into 3 simple steps on how to use both the addition and subtraction, okay? So I'm going to write it here. So we have 3 steps for adding, okay, or subtracting vectors by using the parallelogram method. Okay. Okay, so I'm gonna see if I can just summarize this so that it will be just 3 steps that you can use to do this. So the first one, so because I have both addition and subtraction, I'm going to see if I can break it down into 2. So step 1, I'm going to first start with addition, okay? Then I'm going to then do subtraction, okay? So basically what I'm saying that if you're adding, so if you're adding 2 vectors, so let's assume you're adding vector v and you want to add maybe vector w, okay? So you have to first draw the 2 vectors so that they have the same initial point. Okay? Now, but if you're doing subtraction, okay? So now that's for addition. Now, if you're doing subtraction, what you have to do, so that means, for instance, if you're subtracting, so if you're subtracting 2 vectors, v minus w, let's assume you're subtracting 2 vectors. Now, the first thing you do is that you then have to switch the direction of the second, which is W, so you can create the negative W. Does that make sense? So you have to first switch the direction of the second. So that means the W, okay? So that you can create the negative W, okay? So I've explained that concept already. So when you've done that, then the next thing then is that you then, similar to what you did the first time, so you then draw the vector v, okay, and vector w, but this time it's going to be the negative what? W, so that they have the same initial point. The same initial point. Okay. So that is what you do for if you're adding and you're subtracting. Okay, so now when you're done that, you can now go to step 2 in both cases. So it does not matter if you're adding or subtracting. Step 2 is going to be the same thing. All right. So what you do, you then have to then draw a parallelogram. with the two vectors. As two adjacent sides. Then when you're done with that, so step 3, so the first thing you do is that you then have to draw a vector, which is going to represent the resultant vector, okay? So you have to draw a vector from the initial point. Okay, of the two vectors. With the opposite vertex. Of the parallelogram. Okay, to create a diagonal of the parallelogram. Okay, then this vector so this vector is the sum or the difference of the two vectors. So if you're adding, that resultant is the sum. If you are subtracting, it's going to be the difference. Of the two vectors. All right, so that is it. So those are the 3 steps, okay, of using the adding or subtracting. So the first thing, if it's adding, you just go straight, you join it from 2 initial point. If you're subtracting, you have to flip the one that you're subtracting, so you can get a negative sign, but you have to maintain the magnitude. Then you now have to draw the 2 adjacent sides, and then you now draw a vector to the resultant vector from that initial point to the adjacent vertex so that you can get the resultant sum or the resultant difference. Okay. So what I'm going to do, like I said, this video I'm going to break into 2 parts. The second video is going to be the part 2. So there I'm going to solve examples, all right? So please get conversant with these rules. Make sure you've written it down in your notebook. Then I'm going to see you in the next video where we're going to solve some examples and we're going to try as much as possible to see if this makes sense. So if you can apply this to solve any particular questions, all right? So I'm going to see you in the next video. So I'll see you soon.